Hello there, ladies and gentlemen. So, what we are going to be talking about today is the dirt on soil. So, we've done all kinds of labs with it. We did the soil fertility lab, then we did the texture, then we rolled it up into a ball to see what would happen. And then, what else did we do? Oh, we did the water retention. So, all of these labs gave us information about soil and why it's so important, right? So, let's look at the individual pieces or the properties of soil, okay, and then we'll talk about why they're so important. Got it? All right, so the first one is texture. Okay, so texture. Oh, let me bring this in. Oh, look at how great that was. So, texture. There are three types. Three types of soil. That are different sizes. Which are usually all mixed together. Okay, you remember when we talked about when we did the texture in the palm of our hand, and then we felt it with our fingers, and we felt those different sizes with the sand, the silt, and the clay, and then we did the loam, and it had all different kinds of sizes, and then the local soil had all the different kinds of sizes, but we've learned that it was a little more clayey than the others. But then when we rubbed in our fingers, we felt even that they had different sizes in that loam and local soil, right? And then we looked under the microscope. Do you remember looking under the microscope? Please say yes. And you saw that the sand and the silt were more crystally than the clay. And then if you looked at the loam and the local soil, what you should have found is all different sizes in those when you looked in the microscopes. Okay, so I have a little picture here. It's not the greatest picture, but I got one. And who can tell me what this one is? I think I heard it. Did I hear it? Fantastic. This is the sand piece. You are absolutely right. And then we said the next size piece is what? Silt. Very good. And then that itty bitty piece that's like smaller than your pencil tip. Clay. Good job. Okay? And then when we're feeling these things, the sand, who remembers how the sand felt? When it was just the sand. Remember when you're feeling it in your hand? Right. It was the gritty stuff. It was really gritty. And we said it would make a perfect microdermabrasion, right? And then the silt, that was the fine stuff. When it was dry, it felt really powdery. And then the clay, you remember when I told you rub it in your hands, rub it in your fingers, and it got really sticky, but it was really smooth? So clay, when it's by itself, is smooth and sticky. So that should have been a dead giveaway for our local soil. So the first one is texture, and that's how it feels, remember? That's why we did it in the palm of our hand and in between our fingers. Good job. The next one, next property is color. Okay. And color, soil is all different kinds of color. If y'all remember me showing you the picture of the different layers, where we were looking at the pictures of the different layers and all those different colors of soil. And what color does, it explains the minerals. Okay, those minerals that are in the soil and how well, well or poorly, and so how the soil will drain. And when I'm talking about draining, what am I talking about? Right, drain the water. Good job. Okay, so and we got all different kinds of colors, right? Remember we did the red rocks, and I told you that was going to turn into clay. So if you have red in your soil, you've got iron in it because it rusts, and if you've got yellow in your soil, it's got some sulfur in it because sulfur is yellow. So those different colors tell us the kind of minerals are in the soil. Okay. The next thing we have, and this is typically on the top, is the organic matter. Oops, I spelled matter wrong. The organic matter, or humus. Okay, this is generally found on top. On top of the soil. Okay. Now, what organic matter is, you remember, organism, that means a living thing, right? So, what these are dead and decomposing. Animal and or plant matter. Okay, so these are dead and decomposing, so they're breaking down, breaking into little bitty pieces, right? Breaking down. And so what this is doing is this process puts nutrients back into the soil. Okay, breaks everything down till it's very minute, very, very small pieces. All right. Our next one is that water retention. You remember that water retention lab that we did? Where we put the different soils in the coffee filter and we poured, I think, what was it, 50 milliliters of water? And we saw which one held the most water. And what we should have learned is that clay has a very high retention, so it holds the most water. It saves all that water for itself, and that's because of this sticky mess here, right? The sticky mess says, oh no, you ain't getting none of this water, plant. So that's why clay is not so great for plants. But then the sand, what we should have learned is that the sand, it went through really, really fast. And not only did it go through really, really fast, but almost all the water came out because of those big old pieces. See how big they are comparatively? Those big old pieces of sand had lots of holes in them, so that water just goes right through those things. So the water retention is how the soil, to retain water. Okay, that's how that soil keeps that water. And if it has a high retention rate, that's too much water, like clay. And if it has a low retention rate, then that's not enough water, like sand. I thought I heard somebody say that. I knew y'all were so smart. So, our water retention. And then we have our ability to grow. Our ability to grow is extremely important because why do we need soil? I thought I heard somebody say it. Did somebody say it? Dude, I know. Y'all are like the most ingenious people I know. So, right, that ability to grow. We need soil so that we can grow plants so that we can eat, right? Okay? And have oxygen to breathe. Good job. So, the ability to grow plants was the last one. So, what's important? First off, the size of holes in the soil to hold water. So if you have really big holes like you do in the sand, then that water is just going to straight through it, right? Okay? And then if you have itty bitty holes, the water is going to get trapped in there, and then it's going to stay in the soil instead of going to the plant. Okay? And the next one is the amount of organic matter to supply what? What did we learn? What goes back in there? Nutrients. Good job. The amount of organic matter to supply nutrients Okay, and then the texture. The texture for the roots to grow deep. Okay, now our best soil. Our lab was wrong. Okay, so the best soil to grow plants in is actually loam. So okay, now the reason that loam is the best, because it has all of these things. Okay, it has, I'm going to make this go out. Okay, it has color, so it's got lots of minerals in it. It's dark in color, which tells us that it's got lots of organic matter. So it's got lots of nutrients to give the plants, right? Its ability to grow plants. It's got those holes in it, all different size holes because they're all different size, all different kinds of sand, all different kinds of soil in there. And then it's water retention. It doesn't hold all the water. You know, there's some sand mixed in there and some silt mixed in there that doesn't have that sticky stuff that holds that water from the plant. Okay, so our loam is the best soil to grow a plant in. I know our lab didn't say that. I don't know why. I don't know what we did wrong, but loam is the best soil to grow stuff in. Okay, so because it has all these properties. Okay, so what are these again? Oops, I need my black marker. Correct. These are, I hope y'all can see it, properties of soil. So, I don't know if y'all can see that. Nope, you can't. So, there we go. So, I'll pause this during class so y'all can finish writing. And this is the end of our soil